These examples go with lesson 8.2, hypothesis test for a population mean, standard deviation known. This is part 3 of 4. Example 13. For each of the following p-values, state whether the result is statistically significant at the 0.10 level. All right, remember what we're testing. We said if the p-value is less than or equal to the alpha value, then we should reject our null hypothesis. And if we reject the null hypothesis, then yes, that is statistically significant. Our alpha level is 0.10. So our question here for part A, if the p-value is 0.08, is 0.08 less than 0.10? And it is. So we would reject the null hypothesis and we would say, yes, this is going to be statistically significant. Now let's look at part B. The p-value is 0.15. So we want to know, is 0.15 less than or equal to 0.10? No, it's not. It's actually more. And that means we would not reject the null hypothesis, which means this result is not statistically significant. Part C, the p-value is 0.01. We need to know if this is less than or equal to 0.10. Well, yes, it is. That means we would reject the null hypothesis, and yes, this result is statistically significant. And then our last one, part D here, the p-value is 0.5. We're checking to see, is it less than or equal to 0.10? No, it's not. That means we would not reject our null hypothesis and that this result is not statistically significant. Example 14. A social scientist suspects that the mean number of years of education, mu, for adults in a certain large city is greater than 12 years. She will test the null hypothesis, that mu is equal to 12, against the alternate hypothesis, mu is greater than 12. She surveys a random sample of 100 adults and finds that the sample mean number of years is x bar equals 12.98. Assume that the standard deviation for the number of years of education is sigma is equal to 3 years. Part A, compute the value of the test statistic. All right, let's take a look at what we know. Our hypothesis test is, the null hypothesis is that the population mean is actually 12 versus the alternate hypothesis, the mean is actually greater than 12. All right, we are given a sample size of 100, and we are given a sample mean of 12.98, and we are also given a standard deviation for the population of 3 years. The first thing we need to know is the standard error for this, because we're going to use that instead of the population standard deviation when we're trying to calculate our test statistic or our z-score. All right, the formula is the standard deviation for the population divided by the square root of our sample size. And I think if we put this in our calculator, we are going to find out that our standard error is 0.3. So when we go to calculate our test statistic, we're going to take our sample size here, the 12.98. I'm sorry, not the sample size, the sample mean. We're going to subtract off mu0. Now remember, mu0 we can conveniently find right here in our null hypothesis. In this case, it's going to be 12. And then we're going to divide that by the standard error that we just found. And I'm going to put this in the calculator and see what I get. And this is giving me 3.2 2, and then 66666, but let's just round it off to 3.27 because I know I'm going to have to use table A2 when I come down here to part B to compute the p-value, and I'm going to do that up here because we actually need to draw a picture of this. If I put in my normal curve and sketch what's going on, we just found our test statistic. It's way back here at 3.27. This is a right-tailed test because of the greater than, so that means I want all of this area back here. And if I use table A2, it's going to give me this area over here on this side, and then remember I'm going to use my rule of complements to find the shaded area and do 1 minus that area. So we know we're going to do 1 minus to get to the shaded part right here. So let's pull up table A2 and see what the area to the left with 3.27 is. And table A2 is showing me that the area over here, the white unshaded region, is 0.9995. So remember, to get this shaded area over here, we're just going to do 1 minus that. And I think when I put this in my calculator, it's going to give me 0.0005. All right, now for the interpretation of the p-value, this is the one where we have to write the book, remember? So I'm going to erase all this stuff over here, and then we're going to see if we can write that interpretation down. All right, so I've written in part of our interpretation right here. Assuming the null hypothesis is true, the probability of observing a test statistic as extreme or more extreme than 3.27 is our area up here, which we said was 0.0005. Now remember our threshold for unusual, it was 0.05. So that means this is an unusual occurrence, which makes our results statistically significant. And since it's unusual, this is pretty strong evidence against the null hypothesis. All right, so here's the rest of our explanation. This is unusual and could be considered as strong evidence against the null hypothesis. All right, D, now we're going to be talking about rejection. Is the null hypothesis going to be rejected at the alpha level? Well, remember what we're checking for. Our p-value, we want to know if that's less than or equal to the alpha value. Now, the p-value we found is right here. So we want to know if 0.0005 is less than or equal to this alpha value, 0.05. Well, yes, it is. So, yes, we will reject the null hypothesis. What about part E? Are we going to reject the null hypothesis at the 0.01 level? Again, we ask ourselves, is our p-value 0.0005 less than or equal to our new alpha value 0.01? Yes, it is. So once again, yes, we will reject that null hypothesis. Example 15. The following display from a TI-84 Plus calculator presents the results of a hypothesis test for a population mean. And this is the printout that would appear on the TI-84 Plus calculator. Now part A is asking, what are the null and alternate hypotheses? Well, if we look up here in line 1, this is going to be our alternate hypothesis. And so the null hypothesis is related to the alternate hypothesis because I would say 90% of the time the null hypothesis is going to have an equals in it, and then the alternate is going to be either a greater than, or it's going to be a less than, or it's going to be equal to. Now there are exceptions, and Alex will have some questions in there where sometimes you'll have to put in less than or equal to, or greater than or equal to, but I think you'll know which questions those are when you get to them. All right. So our null hypothesis, we'll do that in just a second. But our alternate hypothesis is given to us, and that is that mu is not equal to 15. Now this is going to be a two-tailed test right here. Our null hypothesis is just going to be that mu is actually equal to 15. When we look at part B, the value of the test statistic, again, conveniently given to you right here, because remember our test statistic is in fact a z-statistic. And you don't have to write out all these decimal places here. It's usually enough to round it out to 3 decimal places, although I think I usually do 4, so I'm just going to write that as 0, 7 to 8, because that 5 would round that 7 up to an 8, and that'll be good enough. Part C, what is the p-value? Well, again, conveniently given to you. If we take a look down here on line 3, we've got p equals. And again, you don't really need to write the whole decimal out. I think if you round it out to 3 or 4 decimal places, that's going to be good enough. So we're going to have 0.0382, and again, that's because that 9 rounds that 1 up to a 2 there. And then the last question here, are we going to reject the null hypothesis at the 0.05 level? Well, what are we checking? We need to know, is that p-value less than or equal to the alpha value? Alpha is given to me to be 0.05. The p-value we just had on the line before is 0.0382, less than or equal to 0.05. Yes, it is. So yes, we will be rejecting the null hypothesis. All right, example 16, the following output from Minitab presents the results of a hypothesis test for the population mean. I don't think the school actually has the program Minitab, but the questions tend to pop up in ALEKS and they pop up in the textbook and on the test. So we want to be sure that you have some exposure to them so that you'll know how to answer these questions. Question A, and this is going to be a lot like the TI-84 problem from previously. Everything you need is up here in the printout. Question A, what are the null and alternate hypotheses? Well, right here is the word test, so if we look on line 1, that should give us our null and alternate hypotheses. And conveniently, it's telling me exactly what I need to write. Mu is equal to 53.5 versus not equal to 53.5. So we just need to know the first one is our null hypothesis. Mu is equal to 53.5 versus the alternate hypothesis. Mu is not equal to 53.5. All right, part B. What is the value of the test statistic? Remember, that's just a z-statistic, and that conveniently is given to us right here. And it's also rounded to 2 decimal places, so that was kind of nice. Z is equal to negative 1.29. All right, the next one. What's the p-value? Well, the p-value is located right here beside it. The p-value in this case is going to be 0.196. And then finally, at the bottom here, do we want to reject the null hypothesis at the 0.05 level? Well, we're checking to see if the p-value is less than alpha. Is 0.196 less than or equal to the alpha value 0.05? No, it's not. We will not reject the null hypothesis. Example 17. A 95% confidence interval for mu is computed to be 1.75 to 3.25. For each of the following hypotheses, state whether the null hypothesis will be rejected at the 0.05 level. Part A, the null hypothesis mu is equal to 3 versus the alternate hypothesis mu is not equal to 3. What we're actually trying to do is we're going to be looking at the mu0 right here, and we want to know if this mean is included inside the confidence interval. If it's there, then we are not going to reject the null hypothesis because the actual mean is included in here. So for this one, 3 actually does fall between 1.75 and 3.25, so we will not reject the null hypothesis. Now when we look at B, now we're going to be looking at the 4. Now 4 is actually more than 3.25. That's out here to the right. It is not included in my confidence interval, so we will be rejecting the null hypothesis here. Part C. The null hypothesis mu is equal to 1.7 versus the alternate hypothesis mu is not equal to 1.7. We're looking at the 1.7, and y'all, it's just barely outside this interval, but it is smaller than our lowest value of 1.75. So yeah, we are going to reject the null hypothesis once again. And then our last one right here, the null hypothesis mu is equal to 3.5 versus the alternate hypothesis mu is not equal to 3.5. This is also located beyond our highest value on our confidence interval, so it's not included in there. And once again, we will reject the null hypothesis.